Factors. What is a factor? So a factor is a pair or is a number when multiplied by another number gives you another number. So let me give you an example. Okay, so if I wanted to find the factors of the number 18, okay, let's just start listing how can we multiply two numbers together to get 18. Let's start with the obvious one. Okay? If we said 1 times 18, that gives me 18. Okay, every number has 1 and itself as factors. Okay, let's think, are there any other ways we can multiply two numbers to get 18? Well, we could also say 18 is 2 times 9. 2 times 9 is 18. I think there is one other way. 3 times 6. 3 times 6 is 18. So if we are asked to list all the factors of a number, we will list all of these, and we usually list them in order. So we would say that the factors of 18 are, and we would list them in order: 1, 2, 3, 6, 9, 18. Let's look at another example. Say the question was, what are all of the factors of the number 17? Okay, so 17, as we know, 1 is always a factor, so 1 times itself. 1 and 17 are factors. Are there any other ways we can multiply two whole numbers together to get 17? Well, let's check our divisibility. Is it divisible by 2, meaning is 2 a factor? Well, it's not even, so 2 is not a factor. 3, let's see. In order to see if it's divisible by 3, the sum of the digits need to be divisible by 3. When I add 1 and 7, I get 8. That's not divisible by 3. So it's not divisible by 3. 4. Well, we knew that was one that we kind of have to remember our skip counting. 4, 8, 12, 16, 20. Yeah, it's not divisible by 4. 5. Does it end in a 0 or a 5? No, it doesn't. Let's see, 6 has to be divisible by both 2 and 3. But we know it's not divisible by either. So therefore, 17 is not divisible by 6. 7 is kind of one of those weird ones too. So we gotta, let's kind of skip count. 7, 14, 21. Nope, it's not divisible by 7. 8, another one we have to kind of skip count. 8, 16, 24. Nope. Divisible by 9. If we add the digits, is that divisible by 9? Well, no, 1 plus 7 is 8. So that is not divisible by 9. Okay, and 10, it doesn't end in a 0. So we're running out of numbers. So the only factors of 17 are 1 and 17. Okay. Now this is an example of a prime number. As we mentioned briefly in our last lesson, a prime number only has the factors of 1 and itself. So what I listed over here are the first several prime numbers that we have. All of these, when you can only find a multiplication fact 1 times itself. You can't, it's not 2 times something, not 3 times something, 4 times something, 5 times something, anything like that. So 2, 3, 5, 7, 11, 13, 17, 23, things like that. So that brings us now to prime factorization. What prime factorization is, just there's 2 words that we know. Prime, meaning one of the, like these numbers that only have factors of 1 in itself, and then factorization, it has the word factor in it. So what we want to do is list all the prime factors when they are multiplied together, give us that number. So let's look, there are 2 ways to figure that out. I'm going to take the number 36. Right? 36. In order to find the prime factorization of a number, here's the first method. We are going to choose one of these prime factors that we know is a factor of this. The easiest one, if it's even, we know it's divisible by 2. So 2 times What times 2 is 36? Well, that's 18. Okay, so 2 is a prime number. Let's just keep that one over there. 18, we can split. We know that's even, so that's 2 times something. 2 times what is 18? 9. Okay. So here's a prime number, here's a prime number. 9 is not a prime number yet because 9 can be broken into 3 times 3. And these are prime numbers. So we look at all of our prime numbers at the bottom of each of these little branches. Our prime factorization of 36 is 2 times 2 times 3 times 3. When we multiply all of those together, we get 36. This is the prime factorization of 36. We can also write it a little bit more fancy way. 2 times 2 can be written as 2 squared times 3 times 3. That's 3 squared. That's a little bit more fancy. Either way is acceptable. Now there's another method to find the prime factorization. It looks a little different, but it does the same thing. It's called the ladder method. So I'm going to start with 36, and I'm going to draw an upside down division symbol, all right, the division box. What I'm going to start putting out here are some prime factors. So I know that 36 is divisible by 2. 2 goes into 36 18 times. I'm going to draw another one of those upside down boxes right underneath. So 18, let's see, 3 goes into that, doesn't it? 3 times 6, so 3, and then I have a 6. Now I know that that's even. Oh, another 2. 2 times 3 is 6, or 6 divided by 2 is 3. Can 3 be divided by anything except 1 in itself? Nope, it's prime. So I have 2 times 3 times 2 times 3. Now we know by our commutative property that we can kind of switch things around whenever we have all multiplication. So we have 2 times 2 times 3 times 3. Look, it's the same thing. So those are your 2 methods to find prime factorization.